Thank you, Alicia. Hi. Well,
I'm sorry, Phil, I think you are muted.
start again. Welcome, everyone. Welcome to this session on network sustainability strategies. My name is Phil Laidler. I'd like to just introduce myself briefly. I'm the Consulting Director at SDL Partners, and I'll be taking you through today's session. So obviously, welcome those of you from the US who are joining us early. Welcome those from Europe. Good afternoon to you. And for those of you hanging on in Asia, good evening to you, and welcome to the session. So we've got a cram-packed session. There are two parts to this. The first part is a series of presentations, which we're going to run through in quick order and quick succession. And then there's an hour of breakout activities after that. So without further ado, I'd like to quickly touch on and introduce our speakers today for this first session. And they are Hannah Paulberg, Sustainability Manager for Service Providers at Cisco, Colin Seaward, Director of Sustainability Data and Technology at Cisco, Gianluca Calabretta, who's the IP and Optical Sales Specialist, Art Janssen, Senior Specialist and Packet Architect from Colt, and my colleague Jack, who is going to kick off the first session, which is taking us through SDL Partners' overall view for the importance of integrating and incorporating sustainability more systematically within our network planning, design, and operations. Over to you, Jack.
Thank you, Phil. Firstly, it's key to be aware that most telecom operators have made strong commitments to net zero. There are now practical steps in place to reduce carbon footprints as part of their sustainability journey, inspired by the pursuit of net zero. However, these are just the first steps, and there is a long way to go for them to be achieved. We also know that sustainability efforts remain fragmented, with targets relating to net zero having varying timeframes. Each telco has its own unique challenges, and while some are still trying to determine what they need to measure and report on in the first instance, more ambitious SPs are focusing on the circular economy and its impact on Scope 3 emissions. I just mentioned Scope 3 emissions. I know not everyone on the call is familiar with some of the concepts we discuss in sustainability, so I'll explain it from the ground up. When companies report greenhouse gas emissions, they talk about Scope 1, Scope 2, and Scope 3. Scope 1 is the direct emissions from fuel combustion, from burning fossil fuels, or from cars that are consuming these fossil fuels. Scope 2 emissions for the telecoms industry mainly revolves around the use of electricity. And for most SPs, Scope 1 and Scope 2 emissions are recorded and reported on accurately, and there are established methodologies for doing so. Scope 3, however, is where most of the telcos' carbon emissions come from. These are the indirect or embedded carbon from our supply chain, other than energy, and it's the embedded carbon from the goods and services that the industry purchases to deliver. These Scope 3 emissions typically account for over 75% of overall emissions, and this is the big challenge. This is what we're going to be talking about today, and relevantly, it captures the impact of an SP's whole supply chain, critically including the carbon emissions released from manufacturing the network equipment that they deploy. And this is the sort of terminology that will continue to crop up throughout the presentation. It's also pertinent to remind ourselves of the current state of play for operators. The journey to net zero is beginning to come under scrutiny. As operators move closer to achieving net zero, sustaining emissions reduction becomes increasingly challenging, especially as the low-hanging fruits are being addressed. So by low-hanging fruit, we're using the picked bunch of bananas on the left-hand side as a metaphor for telco initiatives that have significant impact for operators, but through relatively straightforward actions. The most common initiatives are decommissioning old technologies for newer ones, with more energy efficient alternatives. So for example, transitioning from copper to fiber optic networks, the sunsetting of 2G and 3G networks and refarming the spectrum, etc. Outside of this, there's also a growing pressure from global authorities regarding regulation, with stricter definitions over what net zero actually means and increasing pressure to be precise and specific in reporting. The effect that this is having on operators is that it's causing shareholders to actively recognize that proactive net zero strategies may better position companies to not just comply with regulations, but bring about a competitive advantage. We'll go into a little bit more detail on some of the entities that are employing these regulations and the potential penalties of violation over the next couple of slides. But before that, it's just good to reiterate that this is the road, and it's not getting any easier to travel down with the tightening of legislations. So what is being done by these independent bodies to stamp down on net zero legislation? Let's double click on some of the organisations increasing the demand and having stricter reporting associated with emissions. If we take the US Securities and Exchange Commission, only last month the SEC fully adopted a change in regulation that demands US and foreign private issuers must disclose climate-related metrics in registration statements and periodic reports. This is inclusive of climate-related risks and has a required disclosure of Scope 1, Scope 2, and critically Scope 3 emissions. And the rationale behind this is to provide investors with consistent and comparable information on investment decisions. And it's exactly the kind of external pressure I alluded to in the previous slide. And for lots of companies, this legislation will apply in addition to other mandatory sustainability reporting frameworks. Separately, in 2023, the International Sustainability Standards Board, ISSB, issued its inaugural Global Sustainability Disclosure Standards. So that was IFRS S1 and IFRS S2. The first relates more broadly to sustainability-related risks and opportunities, and the second sets out specific climate-related disclosures. What we're seeing is Australia, Hong Kong, Singapore, and the UK. Companies within those countries are planning to adopt these stricter standards and frameworks, tying nicely together with sort of the corporate and financial reporting of organisations. And this is a big impact, and some companies have already started to adopt it. For science-based targets, the standard of net zero itself is what is being tightened. The definition of what is classed as net zero is becoming increasingly strict. So, for example, by the definition of the SBTi, you can no longer use offsets, or you at least can't use offsets from tree planting. You can only balance from within your supply chain. So what does this mean for telecom as well? It means sequestration, which is extortionate in cost and is also limited in usage. So overall, again, much stricter, again, showing this road to net zero is getting harder and it's getting barriers. And finally, only a couple of months ago, the EU's Corporate Sustainability Due Diligence Directive, the CSDDD, was approved by the EU's Council. And this will see an introduction of very strict reporting for an initial wave of companies across the EU by 2027, which will then be expanded in the midterm future. So we're seeing this regulatory tightening. But what are the risks of not abiding by this tightening? Well, we're also seeing lots of companies come unstuck with their reporting. The reality is that greenwashing is not just about public shaming anymore. It's actually being treated as fraud and thus has financial implications. Today, it's mainly been the financial institutions that have been penalised for misreporting emissions. DWS and Goldman Sachs are examples, but other businesses are starting to come under pressure. It was recently announced that by the Attorney General of the New York State that it was taking JBS, a global meat company, to court, not for misleading consumers over their current emissions, but actually over their future plan for net zero not being sufficiently credible. JBS are making a commitment to net zero for 2040, but their plan is not credible in realising this goal. You can no longer make unreasonable statements and claims about how you're going to get there. And it's interesting that the misdemeanors of the past are not the only things being scrutinised, but now also future plans. So what can be done? What are the actions that operators can take to address the pressures and contribute a more strategic approach in tackling scope emissions? Broadly, operators need to take technology-related actions. This is about coming up with resilient, scalable architectures, right-sizing to have more modular design and leveraging AI. But ultimately, all of these technologies that you hear about a bit more in following slides and during Colt and Cisco's presentation, they only work if the organization is able to interpret, identify, and promote sustainable technologies in a systematic way. It's no longer enough to simply identify technologies to assist us with this journey. There needs to be put in place governance whereby we can adopt sustainable solutions systematically and bring them into the decision-making fabric of an organization. And our belief is that organizational action is needed to maximize sustainability outcomes for technology. So these are the key technology areas that we've identified as most relevant to today's session, and we're going to be discussing them in a little bit more detail. Targeting a converged, resilient network, simplifying the architecture through resource sharing It means an operator can run multiple network services over the same physical infrastructure. It reduces all scope emissions, as there's no longer need for separate networking equipment, for separate management systems, and the supporting of the resources for multiple layers. Instead, traffic can be transported on the same architecture with a lower number of devices, leading to less consumption and less embedded carbon. Secondly, operators are desperate to extend the useful life of their infrastructure. Longer hardware life cycles mean fewer renewals and therefore less embedded carbon, less e-waste and less emissions through not having to dispose of old equipment. A way in which this can be remedied is by investing in future-proof equipment with modular components. In non-modular networks, if one of the components needs replacing, the entire infrastructure needs replacing. But with modular networks, just the individual component in need of an upgrade will be replaced. So again, this can sort of help renewals. And finally, this idea of automation and optimization. It's another key principle where operators can enhance networks to reduce all of the scope emissions. AI can be leveraged to provide active network assurance and health monitoring to detect issues before they arise through the introduction of a more proactive way of monitoring the network. This reduces the chance of emergency outages that require manual visits, and it means that telco engineers will have to make fewer visits to the field, reducing the number of truck rolls and associated scope 1 emissions arising from that vehicle and that truck roll. Furthermore, a lot of operators have yielded positive results from adopting advanced automated energy saving features such as sleep modes that switch off network resources that are not in use, reducing energy consumption of devices in line with demand. AI and machine learning provides more granular prediction, which enables more dynamic and real-time scaling of equipment's energy usage to meet this user demand and maximize the potential of energy savings. Separately, for many operators, traffic routing is currently only partly automated. It's often focused on prioritizing a path that minimizes the risk of congestion and offering the best end user experience based on network capacity. For optimizing the design of traffic routing, full automation allows operators to define parameters to be prioritized by the most energy efficient paths during service provisioning. Art in the next presentation, we'll show a case study example of this. But just to sort of summarize, all of these points in automation do not guarantee sustainable outcomes on their own. Instead, it requires multi-layer visibility and that organizational direction I referred to fully utilize its potential. Before we start to think in greater depth about some of the organizational actions that can be taken, it's worth considering the existing barriers that are restricting telcos from guaranteeing sustainable outcomes. The first is organizational resistance, which doesn't need too much explanation. A second is this idea of operational expediency, the idea of cutting corners and prioritizing immediate goals over long-term sustainability. All of these technological changes are all well and good, but what they fail to consider are poor operational processes and human practicality. For example, if there's an issue with your network, a field engineer is much more likely to throw in an extra line card to increase capacity and add redundancy, when instead what they should be considering are other workarounds to achieve a more connected design and the future proofing of a network. And this really needs to be sort of discouraged and can be remedied through better visibility control and automation. I mentioned organizational resistance as the first barrier, but we also have to consider the resistance of individual teams and departments within an organization. Teams are often segregated and have siloed ways of thinking, different motivations, different incentives. One team's way of pursuing sustainability does not necessarily equal another's. And whilst everyone has this top-down initiative, it's clear that teams aren't interacting with each other to decide the best approach for solving sustainability issues at hand. And it makes the outcomes harder to achieve. Teams also have limited tool sets to address the issues they are facing. And finally, there's still this reliance on legacy systems which require legacy processes, and that means that the gains from automation are more incremental. So how can we overcome these barriers and take the organizational actions that I referred to? Well, we need to start thinking about what tools and metrics can be adopted, what processes and incentives can be put in place. How do we get the engagement and the standards and the governance within the organization that we can identify, make use, and incorporate the technologies into our businesses? Despite the significant impact that the technological initiatives can have on a telco's carbon emissions, they will not be enough to get to net zero alone. On top of getting smarter and more efficient at managing physical infrastructure, updating corporate culture, renewing procurement standards, introducing decision-making tools and processes to reflect sustainability throughout all departments of telco are of paramount importance. Organizationally, sustainability is built into the core of how the best practice telcos operate. For other operators, they should pursue this by actively investing in metrics and tools to drive sustainability and innovation throughout their organizations. And that's particularly pertinent within the procurement process, for example, by using a more granular total cost of ownership measurement, and by seeking out vendors that have established sustainability metrics. By approaching these vendors, operators will be able to monitor performance metrics in the field and ensure specification promises are actually being met by performance. The organizational aim should be to make sustainability more systematic and incorporate a more sustainably focused mentality across all business areas. So just to sort of bring together what I've been speaking about for the last 15 minutes, we've got these targets in place. It's tough to achieve these goals, and it's only going to get harder. We need to incorporate the best practices for technologies, the best practices for architectures, and in order to do this, we need to change the way we make decisions relating to them. We need to start tailoring to future requirements straight away, and on screen are just a few of the kind of thought-provoking questions that it would be good to consider during the breakout session. So how can we drive organizational sustainability to ensure all teams prioritize it, considering those sort of siloed incentives for individual departments, as well as a few other ones on screen. Thank you very much. I'll hand you back to Phil, who will introduce the next presentation.
Thank you, Jack. So great overview there, setting out some thinking that we're going to pick up on later. But I'd now like to hand over to Bart from Colt, who's going to take us through a little bit how Colt is putting some of these principles into practice and how Colt is trying to embrace sustainability in everything it does relating to its networking. Over to you, Bart.
Thank you, Bill. Thank you, Jack. So let's dive in. So my session will cover how network architecture can go hand in hand with achieving sustainability goals, as obviously those are different KPIs. Next, Jack. So Colt's sustainable targets have been marked against our emissions of 2019. As Jack explained, we are looking at the 3 scopes. Some we control ourselves, like scope 1, our own emissions, where we are moving to electrical vehicles fully by 2030. Scope 2 is all about reducing our power consumption, which will be part of my session today, how we are achieving that. And obviously the biggest one, scope 3, is where we are working with our supply chain to see how we can bring down our footprint. And that can be many things. The most obvious or most simple one is business travel cut with 40% we achieved, but also we are looking at recycling equipment, keeping equipment longer. Next. So we are on track with some of our ambitious goals. So if we look at the report 2022, we are minus 30% as Colt Group on all scopes. Very important to notice, we are minus 20% versus 2021 and 2022 on power consumption, a lot to do with how we optimize our infrastructure. And the latest report, which is in progress, we are further reducing our electricity consumption, which is a good sign that we are on track versus our ultimate goals. So next. Where we want to have 100% renewable power by 2030. But also we are moving to net zero 2045 goal, really reducing 90% scope 1, scope 2, and scope 3. And to explain a bit how we've done that on the networking side, but also what added value we want to bring by some of the evolutions we are taking on, let's move to the next slide, where we first will start talking a bit about the history of our network, which is IQNet. It's a generation network we started 2017 with traditional PEs. In a simplified presentation, big boxes, lots of power consumption, so obviously not green. We looked at that design in 2021, next, and we said, let's change the components. Let's look at the components, what makes sense to do. So the most obvious one is to move the big PEP router to the edge, so out of the core, so that intercity traffic or international traffic does not pass a power hungry, but also a costly device. We introduced pizza box style PEs or service routers, which are a fraction of the space, fraction of the power. And next, the most important piece we did is we went to very dense terabit silicon to build a metro and international core where we are enhancing with RON, routed optical networking. So we brought forward the coherent 400 gig pluggables, both in metro, but more importantly on the long distance network, achieving at that time distances up to 460 kilometers, reducing next some of the KPIs. And this is where it becomes interesting. So by changing your architecture, you're obviously meeting the traditional KPIs of a service provider, do more with less. We are able to scale up capacity at 35 times. We reduce rack space, which is very expensive as a lot of the network is in third-party locations. Obviously, the most critical piece is reducing your cost per gigabit, reducing your core transport costs. So all the traditional KPIs look green, but more importantly, we were able to slash down our power consumption on the various aspects of our network, where in the core we went down with minus 97%, which is a very good result. And next. So how are we going to do the future? So if we go through the first building block. Next, yeah. So we are going to do more routed optical networking. So we are going to really scale up to 100% RON, which means distances up to a few thousand kilometers. So within Europe, for us, up to 2,500 kilometers looks like the maximum span we need to cover. So coherent pluggables are the way to go to keep growing the network, which means less power consumption, fitting in pizza boxes with double-digit terabit capacity, but also reducing the amount of components we need on the optical line system. So we will move into 800 gig long range ZR+, which we are going to test later this year. And then it's all about sweating the assets in the metro. So we are reusing the coherent pluggables to scale up capacity between data centers in metro. So there we are introducing Pulse, a pluggable optical line system, which mainly is an SFP with an EDFA in there, allowing you to take on multiple coherent pluggable connections. As you can see, it's scalable. You just patch the next one. You can do 4, 8, or 16 channel. And the idea is very cost efficient with no optical line system without wasting other resources. Reuse the same fiber pair. You can do 4, 8, or 16 channels, high speed capacity between two of the key metro locations, which is the way to grow the network. On the other end, we have seen the benefit of augmenting visualization of the services, and visualization goes in all directions. We talk about traditional on-net probes, typically the well-known Y171 Twamp Lite. We are using probes to measure into third-party locations, which could be in the cloud or which could be a third-party DIA providing an SD-WAN. But also we are looking at reporting on the sustainability parameters for a customer circuit. What is the wattage the customer is using per service, and how can that translate in a sustainability coefficient, how green the service is over Coles network. And to do that, we are moving to denser silicon. So it's the same story we are repeating from 2021. We are moving to silicon where we can fit up to, let's say, 40 terabits in 1 to 3U devices. So more scale, less space, lower cost, but very important, less watts per gigabit. If we look at the next slide. So how we are going to visualize and make it possible for our customers to see what is their footprint, but not only that, what is the SLA they are going to get and how this is their service performing. So on the packet side, we are taking a BGP-LS feed from the network. We have developed together with Cisco several apps. This is the Path Analytics app, which is the first piece of the story. That's mainly any circuit, L2, L3 on Coles packet network. You can visualize how it gets from A to B, real time, but also historical, where it is showing hop by hop how a packet reaches its destination, showing the obvious values like delay per hop, which is coming from second routing performance monitoring. But you will see on the left, we are also now showing the wattage per gigabit or the wattage per service. And this is an extra metric we want to add in all our reporting. So what you see here is a performance monitoring reporting platform. So if you move to the next slide, what we are doing is we are collecting telemetry data from our routers, how many interfaces are enabled, what is the total amount of interfaces enabled per router, what is the wattage consumption per router. And this is very interesting information because you see you have an app which is collecting topology, which is collecting through the IGP the delay and packet loss on all the individual links. And on the right, you have a new app called the Green app, which is taking telemetry from the network, optical packets, what is the consumption wattage per router, but also what is the total enabled bandwidth on that router. Next. And that gives us a very interesting opportunity because this example I'm using here is a financial customer circuit on production, London, Copenhagen, 10 megabit. And what you now can see is we are able to derive an average watt per gigabit from the router by doing the simple math, wattage divided by enabled capacity. And the formula is that simple because we've seen even if we enable more interfaces on the router, the ratio remains the same. We still have a similar ratio watt per gigabit. And in this example, you can see on the 10 megabit service how low the wattage is per hop. Ultimately, if we click next, this is giving us some interesting insights. And this also opens up the door to measure how good are we doing on the networking side to meet sustainability goals. So it's not just a customer reporting metric, it's also a called network-wide metric we can track. So we can now see if our actions are providing results. If you take this example, you see from Copenhagen to London, we have multiple core routers. Each of them contributes to the total wattage per gigabit, or in this case, a 10 megabit circuit the customer circuit uses. But if you look at the first router in Copenhagen, this is an older generation, more power hungry, less dense capacity using traditional gray 100 gig into an optical line system, where all the others are newer generation, in this case, Silicon One Gen 2, so Q200, with coherent pluggables installed. And what is interesting, you can already see the, let's say, the modern core routers have 78 or 6% less power per gigabit versus the older generation. So all of this info together is very powerful, not just for customers to see how sustainable their services are, but also for an operator to track, are we taking the right actions and where can we improve things? And next. So having that data allows us to look at carbon intensity per service. So we know the path, A to B, we know hop by hop. We also know, using our own database, how green is the power we procure in each location. Let's say Core 2 Hamburg, an Equinix data center, how green, or what is the gram CO2 equivalent kilowatt hour from that location. So we have that data internally for all our locations, which means we can do a formula to calculate a new metric to steer traffic, and we call that the greener path. So Flex Algo, people might know, is capable to do, let's say, delay-based traffic shortest path routing, but there is now a Flex Algo enhancement, which is called the generic metric. We are looking at populating the generic metric with a carbon intensity value, which allows to steer traffic based on how green the end-to-end route is. So this gives customers an opportunity to decide traffic engineering-wise which KPIs they want to mix to provide a service end-to-end, but also to see upfront what they are going to get. Next. And when we talk about traffic engineering, this is a very important one. So we are moving to, let's say, intent-based, you could call it cloud-like deterministic path services. And if you click next, you can open up the full slide. We can go through it. What it means is there is an intent. An intent can be anything. It could be, I want an unprotected path between two locations. I want to have an unprotected, but I prefer to be on the greenest route. But I don't want to have a latency which is above 100 milliseconds because the greener path could take some strange corners through the network. So if you click next, an intent can be multiple things. Could be a single thing, but you can also combine it. You could say, I want an unprotected with the greenest path, but I also want a custom SLA that the latency doesn't go above a certain value, or I want two disjoint services. where the primary one should be the low latency one, the secondary one, I prefer it is the greenest one. So you can all do all of these things through the route compute engine, and we can program the path, but we can also again give a preview before you consume the service. And this is a very powerful thing next, because this gives us the opportunity to combine the benefits of changing the architecture. We have a single network to do everything. We have a single network where both layer 2, layer 3 services reside. And we talk about all types of layer 3. That can go from transit to regular DIA or traditional IPVPN or SD-WAN services overlay, but also EPL, EVPL. We can steer traffic over a single network with very efficient dense silicon, combining the power of cost-efficient, power-efficient, let's say, coherent pluggables. You need to have the enablement tools to orchestrate, but also to visualize how an intent will look like, not just the path, the SLA, but adding, let's say, metrics like power and, let's say, a carbon footprint equivalent per service. And if you click next, and this is a very important message, blue and green come together. We have the traditional network architect KPIs, more bandwidth, less cost, less space, less power. But now this taps into achieving sustainable services for our customer, but also for ourselves, and also proof, because there's a lot of, let's say, theoretical talking how to measure. The main thing is how do you prove that what you're doing makes sense, and how do you make your customer, let's say, convinced that when he consumes something, he know what he's going to get metric-wise. And then on the last slide, this opens, let's say, an opportunity to look at ML AI, and I'm not looking at ML AI as an AI ops use case. You have to see, we have many data lakes. You have a data lake revenue per location. You have a data lake cost per location, cost on rack space, power, operating the network, the type of technology, size of the boxes. So you have trends, capacity, also your emissions. You are now able to track for all your nodes. So all of that data by itself is useful, but if you combine it and you unleash, let's say, a cognitive capability like AI can provide on it, you can do, let's say, optimizations. You can look at it. How can I optimize my footprint by becoming greener, meet the economics, and still innovate? And this is where I will end my session. This is, I think, a very powerful one, because you can steer traffic, let's say, for any intent, and the green one is one of the major ones. So thank you.
Bart, thank you so much. So an awful lot there that Bart ran through, covering a lot of ground. I know there's been some questions coming in the Q&A. Unfortunately, we don't have time today, but we will seek to get back to you after the session with those responses. And also, Bart, spot on time as well. So that sets us up on perfect timing for the fireside chat. And Hannah is going to talk to Colin about how is Cisco integrating technology and sustainability within its business. So over to you, Hannah and Colin, for your fireside chat.
Yeah, hi, thanks for that, Phil. I guess the first thing I want to do is introduce both myself and Colin. So I work within our service providers sustainability part. So really looking at helping you on your journey, and Colin is from our corporate centre. So hi, Colin, would you like to introduce yourself briefly?
Yep, thanks, Hannah. So Colin Seward, I've been at Cisco for around about 24 years. Most of the time I've actually been on the technology end of things. I've been in the Cisco IT organizations. That's around about 23 years of my life at Cisco. And towards the end of that, I was looking at how we started to introduce a sustainability framework inside of Cisco IT. And that then took me into, as you mentioned, Hannah, the central sustainability function. So I now work in Cisco's Chief Sustainability Office, looking at the impact that data and technology can have on sustainability across our company and out to our customers and partners as well.
Yeah, perfect. Thank you for that introduction. Really, really useful to set the scene. So I'm here today to ask you a couple of questions. The first one is, we've heard from STL about the role of global trends and what that's influencing our strategies, but how's that impacting Cisco's strategy, in your opinion?
So I think what's come across in the first couple of presentations is this is getting very real. I mean, we've all felt over the last year or two the impact of climate change in the world which we live, but also now in the companies we're already feeling the pressure of the goals that we've set. For many companies who are on this call, they've probably got their own goals and targets. And for a lot of people, they're coming up to dates where those goals are coming up pretty quickly and they've got to make progress on it. And as Jack talked about earlier, that's putting a lot of pressure on companies to try to make progress and to make sure they're talking about things in the correct way externally to avoid claims of greenwashing. And these are complex problems. So again, in both the presentations so far, we talked a lot about the different geographies, about the technologies, about the legislation. These are really, really complicated problems. And we feel the same inside of Cisco as we're going towards our goals. And we also feel the same challenge that I think everybody does here, which is we're not getting away with doing less to get to our goals. So I think we're all feeling this pressure of we're being asked by our customers to do more, whether it's more bandwidth, whether it's more capacity. We have to do more, and at the same time, we have to reduce our emissions towards our goals. So doing more with less is a really big common theme. So inside of Cisco, as we're looking at our journey, our emissions are similar to Jack mentioned at the beginning. So a lot of Cisco's emissions are in Scope 3. A lot of ours are in our Scope 3 use of sold products. So it's the products that we sell to people on this call. That makes up 70% of our total greenhouse gas emissions. So we look at that like everybody here. We think about our decarbonisation levers. We try to do the analysis on what are the things that are going to have the biggest impact. And then internally, it becomes a real team game. This isn't something that the Chief Sustainability Office alone can do. So inside of Cisco, we've set up something called the Sustainability Council, which goes across the whole of the company. We have representatives from sales, from services, from legal, from finance, from IT, from all the different functions inside of Cisco. And they come together to try to work on this complicated problem. How do we procure things in a better way? How do we work with our supply chain? How do we build new products? And how do we sell those to our customers in a way that gets us towards our end goal?
Oh, thank you. And what role do you see technology playing in helping us get to that end goal?
So I think when I think about the conversations in that council inside of Cisco, technology is nearly always one of the foundational things. So whatever part of the organization is speaking and giving updates in the council, whether it's sales talking about what they're doing with customers, obviously when it's engineering, when the engineering teams are talking about the new products that they're producing, that obviously has a very big technology influence. But right the way across the company, technology really does play a key role. And one of those came up a lot during Bart's conversation, data. So the new technology is really important to see advances, whether it's incremental or whether it's step changes in the technology. But one of the big things that we're seeing that technology is doing is giving us better data to inform the decisions. So as Bart showed in his presentation, that data really becomes a guide as to how much of an impact we're having with the changes that we're making, and helping us to then disclose to customers and other people about the emissions from different services and to try to work out how we optimize that. Getting really good data is hard, and that's something that we're looking at a lot inside of Cisco from all the engineering groups, working out how do our products give better data, how do we put it up into dashboards to inform things, and it's great to see from Bart that sort of presentation showing how that data can then help to inform things in real ways. So yeah, technology is, I think, a real underpinning along with data. And the impact, of course, is within inside the company. So it's great to see all the progress we make within our companies. But it's also that you see that impact of technology beyond the company as well. So within the communities that we all live and work in, you start to see the way that the technology which we're implementing is also helping other industries to decarbonize, is helping other communities as well. And as we continue to see these impacts of climate change, so as I mentioned at the beginning, it's a very real, some of these things happening now. I think technology will also play a really key role in helping us be more resilient to a lot of the climate impacts as we go through.
Yeah, that's really interesting. We see the role of telecommunications providers supporting all the communities that they work with. So it's interesting seeing how data and technology not just helps us, but helps our customers and helps their customers in turn. That's really insightful. And finally, we've got sustainability people on the call, we've got technology people on the call, but we also have procurement here as well. So I was wondering if you've got any insights on advice for them to integrate sustainability into working with the supply chain, such as ourselves, and our experience with our own supply chain.
Yeah, it's a great question. So again, going back to our Sustainability Council inside of Cisco, procurement is a really important part of that council. And as we do things, we think about how we can bring the procurement function in early into things. So as you're bringing in suppliers, you bring in procurement as well. So whether it's direct or indirect, we involve the procurement organization. And a lot of the conversation that procurement has with our suppliers is looking at their goals and again, treating it as a team game. So we encourage our suppliers that they disclose their emissions to CDP, that they make their disclosures public, that they have them audited by a third party, that they do the same with their suppliers as well. So we do that with our suppliers, and then we work out how can we work with them and help them along their own trajectories. So getting procurement involved and thinking when you're buying new services about how you start to include procurement as part of a category within the RFP as well. I mean, all these things procurement is a key part of the overall team.
Thank you so much. Thank you so much for your insights. And if there's any specific questions for you, we'll follow those up afterwards. But thank you so much for your time, Colin. And now we're going to hand over to Gianluca, who is our technical expert in routed optical networking, to discuss sustainability in that space as well. So Gianluca, can you hear me all the way from Italy?
Yeah, thank you, Anna. Thank you, Colin, and all the presenters before me. I have a very nice and easy job now to bring this home. And I like to just give you an insight on how routed optical networking can be an example of how pragmatically and practically a framework can help in embedding sustainability topics and goals and benefit into the network life cycle. But let me start 10,000 feet on what is routed optical networking. And let me start from the fact that if you could move to the next one, Jack. It is really, the foundation is based on technological innovation in the field of coherent optics, silicon, software, and automation. So we are bringing all this together. At Cisco, we have a strategy that has started more than 10 years ago around this area, with organic and inorganic acquisition as well as internal development. And the goal here is to transport all the services that our customers, our operators, our public sectors has to transport into a transport network, right? And doing this, achieving network efficiency, streamlining and optimizing the network, so converging layers to simplify operation, but also pulling everything together in order to simplify management operation, because also, let's not forget, and Bart was really straight to the point, let's not forget that also that Bart is providing a great benefit in terms of sustainability. I want to double click in the next slide on one specific aspect of how routed optical networking is able to achieve this, right? And in particular, delivering and using network layer convergence, physical layer convergence, and using technology innovation around coherent pluggable optics. So how is achieving this benefit in terms of sustainability? Removing a component from the network that are not needed if we use this technological innovation. And those components are the one like the gray optics, the patch cord, the transponder shelf that are power hungry, that are space hungry, and embedding and integrating those functions into a coherent pluggable that I'll show you how it compares to the previous. And so delivering cost optimization, delivering space reduction, and delivering power reduction. This is how some of the figures Bart showed us before are coming from. But why now? So why we are making those available right now? Well, because now there has been development in terms of open standard, allowing all our customers to put all the vendors and all the technologies and all the architectures on the same plane and to compare and to interoperate. Because as I said, the technological innovation in terms of miniaturization of transponder function into a coherent pluggable optics are today available at cost and delivered in volume. Also because innovation in silicon and network processing unit are now embedded into routing platforms, allowing to support and consume these technologies. And last but not absolutely the least, unified automation. So the capability of stick together those innovations also from a operational and management point of view. And I like to show you a picture that we took in the next slide at Cisco Live a couple of months back, that is really showing you and giving the perspective of from where this saving is coming from, right? So here we're really talking about the present model operation, or the alternative model operation, let me call it this way, with the separated physical layer where you have all the components that we seen before, versus an integration of IP and optical layers, so a physical layer convergence. And you actually see on the table the picture of the two comparison, right? And the game-changing energy efficiency is coming exactly from this one, right? So you can achieve up to, on the single component, just on the single component, without considering all the commons. But again, the real network figures have been expressed by Bart in his presentation. You can achieve, just from a technology perspective, up to 70% of power savings. But you may say, okay, this is a really disruptive architecture. This is something that is not simple to achieve into a network that can encompass multiple countries, multiple departments, multiple organizations, and countries as well, right? But the next slide, I'd like to show you how we believe that could be achieved, but more than that, how our customers are achieving that, because everything I said is something that we are seeing adopted by the industry since at least 18 to 24 months now. And here is really trying to describe you a journey in terms of adopting this architecture. And it's not chronological order in any form or shape, in the sense that the beauty of this is that we can meet customer needs where they are, and we can meet outcome and use cases, and there are different response and different answer to different use cases, okay? But just for the sake of it, let's start from a phase one where the physical layer convergence that I expressed is achieved integrating transponder function by the use of coherent pluggable optics. And so the convergence of the physical layer of the network, of course, starting introducing automation and management, so that also this journey is started together with the physical layer integration. A second phase can be moving forward in the convergence of the network function with layer convergence. So bringing into this architecture and using the control plane of this architecture that is mostly semi-routing based, to transport all the services that are needed, not only Ethernet and IP native, but also the leased line as well. And increasing in this way also the automation that is pervasive into the network. And last but not least, the third phase that can be the end goal, can be the starting point, a wide end-to-end transformation with also a modernization of the optical transport that does not preclude any architecture or technologies, being ROADM or being anything else, and also can be brownfield, with an extensive use of automation in terms of controller-based multi-layer automation. So to have the capability of visibility, assurance, and the provisioning on the end-to-end network architecture. But Anna, maybe you want to talk us about a specific example in the next slide?
Yeah, thank you so much. So up on the screen here is a worked example so that we can go through some of the theory behind what we're discussing. The top one is a transponder shelf that's very traditional in its layout, and the bottom one is a routed optical networking layout. Now, to avoid us trying to compare old generations to new generations, these are both the latest and greatest technology. So what we're really comparing here is architecture to architecture, if you were to do the same thing today. And even just from looking at this picture, you can say there is a dramatic difference in the amount of hardware going through. But what does that really mean when it comes to what you see in the operationals and what you see from your accounting in the sustainability office? So if we go to the next slide. So these figures that we'll be seeing now are based upon that example. And when we look at doing the assessment on that example, you're looking at around a third less embedded carbon because you're physically putting less hardware in the field. Where you're doing that convergence, it's not only helping you from a operational standpoint and a resiliency standpoint, it's also helping you from that embedded carbon because you're manufacturing less, you're using less materials, and you're transporting less materials. So when we did a fly through of what this could look like, we were looking at 20% less transport if you're using the same mode of transport each way. And then when you come into the use phase, you're reducing that amount of space, like you said before, in this example by 35%, just over 35%. And the assessments was 75% using that standard data. We've seen from Colt that that could be even greater in the field, but this is what this example was looking at. And what's really interesting is when you start wrapping in with the reuse and recycle schemes that we have here at Cisco, you can start to see a world where you could potentially be removing more hardware than you're putting back into it, depending on the system that you're doing. And one of the things that I really like about the solution is that you're connecting more people, you're lowering things like the digital divide in your areas, and you're supporting your communities, but you're doing so whilst also reducing the impact on the planet through both space and power and that carbon, your greenhouse gas emissions within that. And then because you're using less hardware, in this example, we were actually seeing it being cheaper by about 35%. So it's really powerful when you start thinking about how you can get technology, procurement, and sustainability joined together, how there's benefit for all departments. But when we're looking at something that's more transformational rather than traditional, really thinking about and engaging early can be key in building through these robust business cases that support so many of those metrics and so many of those data points that you care about that connect to your own strategies within companies. So I'm really, really proud to say that this is something that we do at Cisco, and thank you so much for your time. We'll dive a little bit more into that within the breakout sessions. Back to you, Jack and Phil.
Thank you, Gianluca. Thank you, Hannah. We're doing really well on time. We're bang on time, even though we have a little buffer of 5 minutes. So it leads me really to thank everyone who's participated in the presentations here today. Also thank you, the attendees, for joining. To say that those of you who are leaving us now, you can get a copy of the recording and the event slides. We'll be sharing that with you. Please also take the time to give your feedback by scanning this QR code and letting us have that. Thanks again for joining us. For those of you staying on,